All right, hello everyone, and welcome to my channel. This channel is for educational purposes, and we look at theories of everything and go deep into them and try to give you a sense of what they're about and how they can help you with your life, your paradigm shifting, or your awakening to 5D consciousness, building your holistic worldview. And today is our 473rd video on the reciprocal system of theory from Dewey B. Larson. And Mr. Larson proposed his two fundamental postulates back in 1959. Just two sentences about how he believed the universe operated. And then he went from there in deducing a theoretical universe. So what his universe would look like if his postulates were correct. And then he compared his theoretical universe with the measured so-called actual universe of the legacy scientists. And we are looking at his 1987 book called Basic Properties of Matter, which is primarily on chemistry. This came out just a couple years before Larson died, 3 years before Larson died, and it goes into, he derives equations for many of the basic properties of matter, like the melting point and the specific heat. In this chapter here, he's looking at thermal expansion. And that may seem like it's a pretty obscure topic, but you have to keep in mind that the reciprocal system is a generalized theory of everything. So the same principles operate regardless of what subject you're talking about. And so if you can understand the principles on something very fundamental, like atoms, then you can apply these same lessons to other aspects and other subjects. And so that's why I think that his study on, especially on temperature and pressure, but chemistry in general, is fascinating. Now, what were Larson's two fundamental postulates? What's he talking about? Well, Larson, it's called the reciprocal system of theory, and other people call it the universe of motion. Larson was in the minority, one of the few people, but not the first, but one of the few people who has attempted to build his model of the universe upon motion. You know, the ancient Greeks built their universe on matter, atoms, and you know, the 20th century scientists, Einstein and Heisenberg, you know, mulled around trying to build their universe on energy. You know, I guess in recent times, people have tried to come up with the four fundamental forces, or the unified field theory, building things on force. Larson built his universe on motion, and specifically a kind of motion that he called scalar motion, which is a more generalized kind of motion, a motion that has a magnitude but has no specific direction, that you envision using a balloon with spots on it that you put on with a magic marker or something. You blow up the balloon, all of the spots will be moving away from each other. But they won't be moving in any specific direction. Every spot will be moving away from every other spot. And even the locations between the spots are moving away from each other. Everything is moving away from everything else, meaning everything is moving in every direction, outward. If you contract the balloon, then everything is moving inward toward each other. And this is, might seem like a, obscure example, but, the investigations of Hubble, even way back in the 1920s, found that all of the distant galaxies are moving away from each other. So that model, the expanding balloon model, also works for this galactic expansion, unless you were to basically arbitrarily decide that our galaxy is not participating in that, and we are at the center of the universe. Now, Larson's first postulate is really where he states the case. The second postulate is more the context for the universe that he's going to attempt to plug in his first postulate into the second postulate to determine the theoretical universe. The first postulate states that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Okay, now let's get to the reciprocal part first. Universe is made out of motion. Motion is the relationship between space and time. This means that space and time do not exist in and of themselves. They only exist together in motion. And whatever is true about one is also true about the other. And these are the mathematical characteristics of all reciprocals. If you know math, even whatever, 5th grade math, that is, 3, the reciprocal of 3 is 1/3. The reciprocal of 4 is 1/4. They both have that same quality 4, but one of them has 4 over 1, and the other one is 1 over 4. And the same is true about space and time. Motion is a fraction, with space or time as the numerator and time or space as the denominator. So one is in the numerator, the other is in the denominator, but they both together comprise motion. And so the most basic example of that is speed. The car is going 12 miles per hour, 12 miles of space in 1 hour of time. Space over time is speed. But Larson extrapolates that to all of our scientific phenomena are different kinds of motion. So matter is a kind of motion. Energy is a kind of motion. Force is a kind of motion. And they all have their space over time or time over space signatures. Force is time over space to the 2nd power. Energy is just time over space. Acceleration is space over time to the 2nd power. Matter is time to the 3rd power over space to the 3rd power. Okay, so you get the general idea. Larson derived those, from other equations, from some of the, historical classical equations of mechanics and stuff. But, every one of our scientific quantities is a relationship between space and time, a fraction, with space or time as the numerator, time or space as the denominator. And space and time and motion all come in 3 dimensions. Now you can see the three-dimensionality of space right in front of your face. XYZ coordinates. This is really what you would call the container viewpoint, which is kind of an obstacle to understanding the reciprocal system, but it is part of the reciprocal system. Larson calls this coordinate space. 3 dimensions of space in a still frame. Space is still, and we are moving through space. And then time is unfolding. Events are unfolding through time. Time is always getting later and later and later and later, but not in any specific direction. So what we're basically seeing is we're seeing that space has become stationary, but time is still moving in a scalar manner. So if you kind of compare that to the expanding balloon that Larson calls the progression, with the dots on it, the motion has been stilled in space, but it is still occurring in time. Okay, so that is kind of our, what Larson calls our spatial stationary reference system, coordinate, space, and clock time. Now, by the reciprocal postulate, there is also theoretically an inversion of that, where we have coordinate time and clock space, 3 dimensions of time in a still frame with x-like, y-like, and z-like coordinates. And then space is progressing. Space is always getting farther and farther and farther apart, like on the surface of the expanding balloon. And so in this case, motion in time has been stopped from that expanding balloon. Like the expanding balloon is progressing both in space and in time. But this temporal reference frame that we're talking of has, that motion has stopped in time, but it continues on in space. So we see what Larson calls coordinate time and clock space. Space is still moving in a scalar manner, like on the surface of an expanding balloon, but time is stationary. So now when we have 3 dimensions of motion, we recognize that it only requires 1 dimension of motion to occupy 3 dimensions of either space or time. And so our reference system is not sufficient to accommodate 3 dimensions of motion. 3 dimensions of motion go beyond the stationary reference system or the temporal reference system. So this comes back to the progression. Larson looks at this outward motion of the expanding balloon as really the source of everything in the universe. And this is motion is occurring at a speed. And Larson calls that unit speed by the discrete unit postulate, which basically says that space, time, and motion all are quantized. They all come in units only. You have to have a full unit of space before you have space. You have to have a full unit of time before you have time. And motion comes only in units. Units of space over units of time, or what have you, depending upon the units that you're talking about. Like we said, energy is time over space. So 1 unit of energy would be 1 unit of time per 1 unit of space. Or matter is time to the 3rd over space to the 3rd. So 1 unit of matter would be 1 unit of time to the 3rd power over 1 unit of space to the 3rd power. So all of our basic quantities they come in units. And for the progression, these are units of speed. Larson calls it unit speed. And unit speed works out to be the speed of light. So this expansion of the balloon is, first of all, occurring in 3 dimensions. And so that might be a limitation of that analogy there. But it's occurring in 3 dimensions, and it is occurring at unit speed. It's occurring from all locations and all times. It's omnipresent and eternal, occurring in every space, every time, all the time. And it progresses at the rate of 1 unit of space per 1 unit of time, which is the speed of light. Larson refers to this as the progression of the natural reference system. So we have our spatial reference system, which is stationary in space. We have our temporal reference system, which is stationary in time. Neither of them are sufficient to describe 3 dimensions of motion. But then we have our natural reference system, which is a moving reference system. And this is the reference system that Larson makes his measurements from. Legacy scientists make their measurements from the spatial reference system. You know, when you say the car is moving 10 miles per hour, it's 10 miles from stationary. But Larson doesn't do it that way. He measures the difference from the speed of light outward in all directions. So that's the natural reference system, and Larson calls that the null point or the neutral point of the universe, which also means that half the universe is moving slower than the speed of light, and half the universe is moving faster than the speed of light. And Larson refers to these as the material sector and the cosmic sector, respectively. And these are inverses of one another. In the material sector, you have the stationary reference system, the stationary spatial reference system. And in the cosmic sector, you have the stationary temporal reference system. But in between them, you have the null point, the neutral point, the ether, which is the progression of the natural reference system. And then within each one of these sectors, just to make an aside, you know, the cosmic sector is pretty much unknown by legacy scientists. They don't believe in that. Einstein says that the speed of light is the maximum speed of the universe. So this is blasphemy to the legacy scientists, this cosmic sector. But they know all about the material sector. But what's great about the reciprocal system is that what you know about the material sector can be extrapolated to the cosmic sector. And so you can have near perfect understanding of the cosmic sector just by understanding the material sector and then interchanging the roles of space and time to move it into the cosmic sector. As you cross that unit speed boundary, you have to invert the roles of space and time. And then within each one of these sectors, there's also a mini region within each one of them. Within the material sector, Larson calls that the time region, and that is within 1 unit of space. Because when you have 2 atoms or 2 particles that are approaching each other to 1 unit of space, they can't approach each other any closer than that. 1 unit of space, by the way, is about 2 millionths of an inch. And when they can't get any closer than that, then what they do instead is they move outward in time, which by the reciprocal postulate is equivalent to inward in space. And we are viewing it from our vantage point in the spatial reference system. We are anchored to the spatial reference system by gravity. And So we see it as a motion closer together in space, but it is really happening in time. Larson refers to this as equivalent space. It's not space, but it is the equivalent of space, except that it is distorted in a number of ways. One of them is that equivalent space is a second power region. So we're seeing a second power thing happening. Also, there is what you call the interregional ratio, which is when you look across a boundary or a sector boundary or a region boundary, you have to reduce what you see by a certain fraction because you can't see everything that's going on in a different region because there's only a one-dimensional connection between those two regions, and you're seeing a three-dimensional thing. And so the same thing is going on in the cosmic sector in what he calls the space region. That's when two cosmic atoms or two cosmic particles approach each other to 1 unit of time. Then the particles can't move any closer in time, so they move outward in space. And then also within the time region and the space region, the directions of the progression and gravitation also reverse, so that now the progression is moving inward in equivalent space and gravitation is moving outward in equivalent space or equivalent time. Now, atoms and molecules, matter, come from the source, from the progression of the natural reference system, but they come by reversing that outward motion of the source of the progression and turning it into an inward motion, which is gravitation, which is envisioned using that same balloon, but now the balloon is contracting. All of the dots are moving toward each other, and this is analogous to gravitation. And so matter is a process of taking that outward motion and reversing it in all three dimensions in order to make matter. And so Larson's periodic table has 3 numbers for every element. Every element has a certain magnitude in 3 numbers. One is a 2-dimensional rotation, one is a secondary 2-dimensional rotation, and they alternate. And then the third is an optional 1-dimensional rotation in the opposite direction, which can be 0 in the noble gases, and it can be positive in the electropositives and negative in the electronegatives. Now, with that background, let's go into a little bit of Larson's work here on thermal expansion. We're in the middle of the chapter, and he just got done kind of discussing, he got to a pretty thorny sentence here. The thermal expansion is due to the thermal motion, which is an intermittent motion moving outward from the time region, which is a kind of a extension of gravitation. And then the progression is pressure would be the extension of the progression, and I'm not sure if extension would be the right word here, but so the thermal expansion, he says, is related to the interatomic distance, which is the kind of the equilibrium distance that matter atoms arrange themselves in a geometrical packing in the time region. And this is the place where the progression is equal to gravitation. Remembering that the progression is constant and omnipresent and eternal, whereas gravitation is based on an as-if force, or based on the inverse square law. So there is just one location where they are the same, and that is what Larson calls the interatomic distance, and that is, where it finds equilibrium, and that interatomic distance can be increased or decreased by an added pressure or temperature. Temperature will increase it, the pressure will decrease it. Okay, so the expansion is related to the interatomic distance rather than to the geometrical volume. Because an atom can take a number of different forms of packing in geometrical, arrangement, and they have different volumes. So an atom can be packed in a hexagonal close packing or a tetrahedral arrangement, and they would have, even though they are the same distance apart, they would have different volumes. And it is independent of the geometrical arrangement. But as indicated in the preceding paragraph, a modification of the geometry does affect the relation of the volume at the solid endpoint to the reference volume at zero temperature. Okay, so zero temperature, I'm not quite sure what zero temperature is. I guess he calls that T sub zero. And that is 2/9 of a unit of temperature. And that is, I don't quite understand if that's the interatomic distance or if that's further out. And then there's T sub 1, which is where you have 1 unit of temperature. And then there's the melting point, which is based on the thermal motion as opposed to based on gravity and the progression. He covered this a couple chapters ago that we went through it, and I honestly have never really understood that. So hopefully I will educate myself and be able to pass it along to you. Let's just continue here. In the NaCl type of structure, the edge of the unit cube is equal to the interatomic distance. This cube contains 1 atom, and the ratio of the measured volume to what we may call the 3-dimensional space, the cube of the interatomic distance, is therefore unity. In the body-centered cube, the edge is 2 times the square root of 3. I actually believe that should be 2 over the square root of 3 times the interatomic distance. Since the unit cube of this type contains 2 atoms, the ratio of volume to 3-dimensional space is 0.770. And, I would die if Larson actually showed his work here so that you could understand it. But what it is it's 2 over the square root of 3 to the 3rd power. So you basically have 8 over 3 times the square root of 3, which is approximately 1.54. And then you have to divide that by 2 in order to, because there are 2 atoms. And so that's how he gets his 0.770 number, which you would be hard-pressed to get, just from his explanation. The 1-dimensional space, the edge of a hypothetical cube containing 1 atom, is then 0.9165 for the body-centered cube and 1.00 for the NaL type structure. So that 0.9165 is the cube root of this 0.770 number. She didn't explain either. Okay, transitions from one type of structure to the other modify the spatial relations accordingly. The values applicable to all 5 of the principal isometric crystal structures of the elements are listed in the following tabulation. Okay, so these are the major isometric crystal structures, and these are the distances for each one given the same volume. Face-centered cube, 0.8909. Close-packed hexagonal, 0.8909. Body-centered cube, 0.9165. Simple NaCl cube, 1.00. Diamond or diamond cube, zinc sulfide is an example of that, 1.1547. And I believe that number is the square root of 3, 8 over 3 times the square root of 3, the cube root of that. Although I'm not entirely sure. The second segment of the thermal expansion curve has no negative initial level because there is a positive expansion, that of the first segment, into which the initial level can extend. Okay, that's why the 0 temperature is occurring at 2/9, because there is a negative initial level of temperature. And so you need 2/9 of a temperature, of a unit of temperature, just to nullify those first 2 negative units. And so the T sub 0 temperature occurs at 2/9 of a unit. In general, the unit of temperature is the full temperature of the liquid over 256. So that's 1.995, it turns out, degrees. And so the that works out to be the temperature at 2/9. Okay, if you follow that, which I would have no reason to think that you would. But just hang in there. You know, this stuff is, it rubs off on you after a while, and you start to make a picture of it. Like the transition from the liquid to the solid state, the transition from single units of motion to multi-unit motion involves a change in the 0 datum applicable to temperature. The temperature T sub 0, corresponding to the initial negative level, is eliminated, and the temperature of the endpoint T sub 1 of the first segment of the curve, which is 9/2 on this segment, is reduced to 7/2 T sub 0 on the second segment. Okay, I'll be coming back tomorrow, and I'll try to explain this last part that he put in here. I'll try to explain it to myself first and see if I can figure it out. And thanks for tuning in today. Come back tomorrow and have a great day.